Thank you. Yeah, the mic seems to work. Thank you very much. So today we're going to talk about the crane moving from a lifting machine to a smart tool. And basically we'll try to answer a question, how will the tower crane become smarter? There's a couple of discussion, we're going through discussion constantly on what's the future of crane, what does it hold, where are we going, what kind of technology we could develop and so on. So we wanted to focus on basically on three subjects that are coming back and forth most of the time. One is the remote driving, the self-driving, and the third one is the digital integration. So these are the three subjects that we picked, which are coming very often to the table, and we wanted to discuss that with you. So the remote driving to start with. When we talk about remote driving in the crane industry, we think about having people operating crane remotely, and most of the idea come from something that already exists from the aircraft industry. So that's an MQ-1 Predator. It's made by a company called General Atomics. It's used by the US Army. It's in operation for the last 15 years, roughly. It's an aircraft. It was originally designed for just for recognitions, but it has moved to have weapon actually on it, and it has been in operation in Afghanistan and other countries, and basically the operator, the drivers, they're operating the plane remotely from some kind of container with all the display and everything. The aircraft was both with a direct communication. That's what we see there, to be able to land and take off. And after that, it's a satellite communication that takes over and pilots the plane in almost everywhere. It's the longest flight for that plane actually was 40 hours long, 40 hours and 5 minutes. So that's the kind of remote driving that we see in the real life. So I think that said, and all sorts of discussion, there's lots of guys, at SMIE and Smart Job Site, we developed a simulator for cranes. And there's many people that said, yeah, your simulator is great, but in the future we'll remotely operate the crane from some places where the crane operator will be nice, warm, or cold, and basically by what we've done, and that's I think pretty close to be a world first, if not a world first. We've done it just to see what it does. So thanks to a training center, which is where we test our system. It's called Émile Picot. It's in the south of France. It's about 300 kilometers from our office. We've done that. Right, so that was last Thursday, so it's quite recent. We prepared that for the show and not to be able to come with something quite interesting. So what you've seen is the simulator been in our office in Montsartou, so it's near Nice. We were remotely operating the crane, which was near Aix-en-Provence in the south of France. There was a 4G communication from both sides. So it was through 4G, and basically we were monitoring the lag, the time difference to operate the crane, and we were under 100 milliseconds. There has been some little drops in the communication, but very, very little, and it's been working for the day. We couldn't work more because the crane had been used for training, but it worked fine. So that's something that could be done. We've done it, and I'm very proud of all the team behind and all the guys that are working on that. And we've got a great team, so I just want to thank them for that. So that's I never heard about something being done like that for the crane industry. There has been some equivalent. I know Dawson had a dozer remotely operated on Boma. So from the tower crane perspective, we may be the first one, we don't know, but that's something we tried and we got lots of feedback from that. So I'd be happy to answer your question at the end of the presentation if you got any. So crane being smarter, remote driving, we've been talking about it, self-driving. So in the real life and in other industry, the car industry, so you're all familiar with this kind of thing. It's the Tesla, there's a couple of other car manufacturers that are actually pretty advanced in terms of self-driving car. So I don't know if there's much to say about that. You've all seen this kind of picture. That one is interesting because you can see actually what the system recognizes and how it works. It uses deep learning and lots of camera, LiDAR, and ultrasonic sensor as well, to be able to know the location of the crane within its environment and to know what's the surrounding and so on. So that's something that there's lots of discussion around that because the car industry is very close. It starts to work in the car industry, so why not our industry? So there's a couple of companies that are working on that subject, and some are more advanced than others. And we announced on Bauma actually that's something that we experience as well for the crane industry. And so just before Bauma, we did that. So that was actually same place. It's a training center. That's where we do all the tests for the system. We equipped the crane to be able to do some self-driving. So it's really a first level. We tie the system actually our system ProSight, the anti-collision system, to the crane, not only to slow down the movement but as well to control the movements. So in the system, there's a feature to be able to go to a location. We click on the display. We say, okay, we're going to go there, and then the crane starts the lift and go to that location and goes down to land at the location that we specified. It's extremely basic in terms of self-driving. There ain't all the technology, the deep learning and the artificial intelligence that will come in the next couple of years, on which we are working. But it was a first step that's quite interesting. We've learned a huge amount compared to what we thought. That's been a very great experience and a first step. There's going to be some next step in the future, and we've learned a lot from that. Again, I will be very happy to answer your question at the end of the presentation if you have any. Third subject, the digital integration. So for us, it's a very big subject. So for us, it's the biggest subject. So let me step back a little bit and just look back a little bit. And what you're seeing there, you've all recognized it. It's the Golf, right? So there's nothing huge about that, but it's just the 7th generation of Golf. And what separates the first one from the last one is actually 40 years. So what has changed in the 40 years? In the car industry, almost everything has changed. The processes almost all the processes changed, and unlike what I'm showing there, which is just a guy that draws the car, after that drawing, everything is digital. The car is turning into a CAD model, which is used for the digital mock-up, for example, with what we are seeing right there. All the guys are designing the car around the digital information. And that's for the design, and same story for the manufacturing. The manufacturing is completely based on the CAD model, on the simulation. All the processes are controlled, and they all are related to the 3D to the digital information, to the data. So if we look back at that picture, from 75 to 2015, 40 years difference. And if you look at that picture, that was in 75. It's actually the Cattenom, it's a nuclear plant in France. And if we look at 2015, if it works, and it doesn't work. That's it, it works. If you look at the two pictures, almost nothing has changed in 40 years. Same process, same crane, almost the same crane. You did very good, your cranes are much more productive, but they're pretty much the same design. There's the same building, the same concrete, the same rebar, same everything really. 40 years difference. And actually there's some fact behind that. There's a couple of studies, I've been digging to try to find them, but there's a couple of studies that actually show the productivity of the construction industry compared to all the other industry, the non-farming industry. And that's the picture on the right. They're saying pretty much the same. Picture on the right where it says that all the non-farming industry has raised in terms of productivity, and that's from 1964. So in the last 40, 50 years, the productivity increased in almost all the industry. In our industry, the productivity actually decreased. And there's reason for that discussion with some general contractor, Steve included. And basically, the processes didn't change. And on the top of that, there's more constraint in terms of safety, which actually is good, but it costs money. And the productivity actually, there's more same processes, same products, and more constraint, less productivity. So what explains that from where we stand is that there's very good reason for that. The digitalization, we've been talking about that all day. We'll carry on with Steve in a minute. But the big difference between the car industry, for example, and the construction industry, when the guy invests in the design, they invest once and they produce tens of thousands of cars. When we invest in the digitalization, that's for one project. And that's what I think explains these figures. And there's many, many good reasons behind that. But the good news is that from where I stand, and I'm going to let Steve explain that to you, from where we stand, we are really seeing, and today was a great example, we are really seeing the thing change now. So we think the digitalization really is coming, and it's very, very close.
Thank you.
Steve.
So I'm part of Select, but we're part of Laing O'Rourke, and Laing O'Rourke's a global enterprise, and we've been trying to embrace and push forward to improve that productivity figure, and also to embrace sort of new technology and safer ways of working. We've got a video that I'm going to show you. It's a bit of a corporate, and I apologise for that little bit, but it gives you a real feel for the sort of technology we're working on and the sort of things we're doing already. So from that you saw maybe the reference to DFMA, Design for Manufacture and Assembly. And that comes back to, we've got a big factory in Worksop, and from that we're trying to build as much stuff off-site as possible. So our ideal DFMA build is 70% of the product coming from the factory, off-site manufactured. The aim is 60% improvement in productivity, and that's that exact figure that Jean-Charles just showed. We're trying to get that up by 60%, and a 30% improvement in delivery. In other words, 30% less program time. I'm just going to show you another video. I know it's very lazy of me, but it's easier than talking. And this one's actually of a project that starts in Manchester very shortly. They're doing demolition at the moment. And this is going to be a full DFMA project. And hopefully that'll explain a lot more of what we're talking about.
Manchester's vast student population reflects its popularity as a first-class destination for higher or tertiary education. We believe our key value proposition stems from our Design for Manufacture and Assembly, or DFMA philosophy, coupled with a well-thought-out logistic strategy. The tower crane strategy has been studied, and the position of the two self-climbing luffing jib tower cranes has been designed to maximize lifting efficiencies and hook time. The superstructure will be constructed using Lang O'Rourke's DFMA suite of products to bring off-site benefits to the project. The use of steel delta beams, hollow core planks, precast concrete columns and stairs, along with MEP risers, pods and utility cupboards are all products that reduce vehicle movements, improve safety, and bring a program and cost advantage to the project, which is the main objective that lies at the very heart of an effective DFMA strategy. By using DFMA, we can achieve a 6-day floor cycle and vastly reduce the quantity of wet concrete on site, negating the requirement for noisy concrete pumps to be located at ground floor, as the quantities can be delivered by the tower cranes using a skip. The beating heart of any building are the services within, usually hidden away in the final product. Without them, the structure is but a shelter. Continuing our DFMA theme, plant, risers and horizontal distribution modules benefit from being factory produced, and once completed, the testing and commissioning can commence long before its arrival at site, thus taking it off the critical path and substantially reducing risk of failure during final on-site commissioning. Safety takes another dimension when constructing at extreme height, and this is where DFMA can bring significant advantages. By planning and designing with this in mind from the outset, we are effectively bringing 70% of the construction activity to the safety of the factory, resulting in fewer operatives on site, which in turn leads to less site activity and therefore less opportunity for accidents. Lang O'Rourke deploys a highly skilled factory-based direct delivery approach. We design, manufacture and assemble architectural, structural and MEP components and systems to meet the highest standards, delivering projects faster, safer, and providing certainty to ensure we deliver quality projects which our clients expect.
You can see there, it's quite a compelling argument. It makes a lot of sense. We've got fewer personnel on site. We've got fewer operations to manage. The operations are safer because there's a lower volume, less people on site, and it's more sustainable. It's obviously going to be greener. We're not delivering formwork and lots of product to site that we then have to take away again. So delivery-wise, it's less impact on the surroundings. There's less risk of delay. Congestion in the UK is a nightmare on the best of days. And then there's less congestion on site. It's a lot easier to manage. But in reality, what this does is it puts more and more pressure on the tower crane. The lifts are larger and they're critical lifts. And our aspiration, as maybe you saw in the first video, is actually modular accommodation and modular housing. So the potential for building 18, 20-story blocks of flats from modules that come out of a factory that are 70, 80% complete. They've already got the kitchen fitted, they've already got all the wiring in, they've got the heating system, they're just getting connected up, lifted into position on site, And in a matter of weeks, a plot of land will go from an empty plot to a finished building. So the pressure on the crane is more than ever. But the point is with it is you can see more and more that you have a very finite plan. The crane, we know what's been delivered to site, we know what has to be lifted into place. We can also plan for, what loads are safe to be lifted at what wind speed, so we can help manage that side of things. It's all about controlled processes. So the crane potentially could know about the schedule, it could know about the deliveries, it could know about the weather conditions. It's all about being predictable and working according to an absolute plan. And that's exactly what those robots were doing in that factory. They're not intelligent. All they've got is a line of code that's telling them to pick up this from this position, hold it here, while this robot goes along and does, welds the joint up. It's not intelligent, it's not smart. I think it's you now.
So yeah, the question we had to answer really, it's how will the tower crane become smarter? And so we got three way to investigate that subject. One was the remote driving. So the remote driving, okay, we tried, we done it. Maybe, why not, we'll see. The self-driving, potentially. But one thing is sure is that the digital integration is an absolute must. And as Steve said, the robot is not smart. If you look at a factory, the robot is not smart. But the crane doesn't have to get much smarter, but it's got to integrate in its environment, it's got to integrate in the processes, and it's got to be fully part of the digital process. That's where the crane will, the job site will actually get smarter. Thank you very much. Thanks for your attention. Thank you.
Thanks very much. And who would like to ask a question, please? Yeah, it must be someone. No?
I've got a quick question. Looking at the self-driving and the remote driving, are you completely convinced that this is going to be effective and actual in a reasonable timescale, or are you still do you still have to convince yourselves about that?
Thanks, Murray. Thank you for your question. I'll remember that. I mean, there's the sensible answer. We tried. We got a lot of experience from that, from both subjects. It's got to be tried. It's two completely different subjects. So the remote operating is, I don't know, I may open a fully open door, but it's just exactly, we find out that actually the interest is, and the drawback for the remote driving is the same than the interest for the remote plane, the remote aircraft. There's no sense of danger. So on the remote driving, on the remote operation, you don't feel the crane, you are in front of a screen, you're seeing a video, and there's a video game in front of you with a crane moving, and you don't feel what's happening, you don't feel the danger. So pretty much maybe like the aircraft where they don't feel that they're killing someone, but if you kill someone on a crane, you would not feel it. So on an aircraft, it's their job, on the crane, it's our job to avoid that. So I don't believe in the remote, don't believe in it at all. And having tried, but after that, there's huge fantasy around these things, so everybody will have to do his own experience. Probably someone will come in 5 years from now saying it's great, it works great, and so on, but we haven't been impressed with the remote operation. We've done it, so we've made our own experience. The self-driving, it's a different story because somehow we know it's going to end up like that, but not now. It's going to take a long time for many reasons. The technical reason first, and the legal reason second. Legally, it's going to take a huge amount of time to get the crane self-driven. So what we've done is to try to line up, on the race to go there, and I like to think that we are quite well equipped for that race. After that, it doesn't make sense. It doesn't make any sense because, just like Steve explained, if a job site is not tidy, If a job site is a mess, it doesn't make any sense to get rid of a crane operator. When you look at the cost structure of a crane operator, costs nothing. Costs absolutely nothing. Getting to improve, we are looking at that this morning. There was a job site that we got remote access to our system now, and there was a job site in the south of France. They spend their time to just go around and do 360 degree all day long. They would move the location of the truck to unload the truck just a little bit closer to where they got to go. They would save weeks. And getting rid of a crane operator doesn't make any sense. Think about your job site, think about your strategy. You save weeks. Replacing crane operator, you save nothing. So that's what I think.
And I agree.
So I think the 3 points, they're still there. The remote driving, okay, it's great. Okay, we've done it. The safe driving, yes, eventually at the end of the road, but the digital integration is absolutely key for everything, for us.
If you look at all the things we do in the tower crane world, we rely on another industry for everything we get was developed by someone else. You know, the motors were made for conveyor belts that are made by the thousand. The control systems are made, you know, from PLCs that are made by the thousand for someone else. And we pull them all together because, you know, relatively speaking, we're low volume. So we're always going to rely on someone else developing the technology. Because if you look at the self-driving technology that Tesla's using, they've spent billions on it. Billions. And I don't think as an industry we can afford billions. Not for that. It's cheaper just to put a driver on it.
Okay.
All right?
It's good to have that perspective on it. Yeah, thank you.
Thank you very much. Thank you.